Hello friends, welcome back. In this tutorial we will study about Griebach normal form, that is GNF. A context-free grammar is in GNF if its productions are of form A derives A alpha, where this small a is a terminal and alpha is either a string of variables or an empty string. For example, see these productions. S derives A, B. S derives B, A, C. A derives A, B derives B, C derives C, C. These all productions are in GNF. Whereas these two productions, A derives A, B, C, A and B derives C, A are not in GNF. Now, every context-free language L which doesn't contain empty string can be generated by a grammar whose productions are in GNF. So, let G be the grammar of this language L, which doesn't contain empty string. Now, we have to convert the grammar G into GNF without affecting its language. So, first step is, first, we will convert the grammar G into Chomsky normal form in CNF. First, we will convert the grammar G into CNF and we will rename the variables as A1, A2, A3, A4 up to AN. And A1 will be the start symbol, right? After renaming the variables of grammar G, modify the grammar G in such a way that its each production is either in this form AI derives A gamma or in this form AI derives AJ gamma, where J is greater than I. Now for this, to modify the grammar in this way, what will we do? We will proceed from variable A1 to AN, right? And check their productions. Now suppose productions for variables A1, A2, A3 up to AM-1 satisfy this condition. But for variable AM, there is a production AM derives AJ gamma, where J is less than M. Then what will we do? We will apply substitution rule. Then, after applying substitution rules, we will keep on applying this substitution rule until we get a production in the form AM derives AP gamma, right, where P is greater than equal to M. When P is greater than M, it means it is in required form, it is satisfying the condition. But when P is equal to M, it means there is left recursion. Now here we have to remove left recursion from this production. So what will we do? We will introduce a new variable Bn in grammar G and remove the left recursion from this production. After completing step 2, we will get at last the highest number variable an having productions of the form an derives a gamma. It means all the productions of variable an will be in GNF. So what will we do now? We will start from variable an minus 1 and proceed to variable a1 by making their productions in GNF by using substitution rule. After this, what will we do? In step 4, the variables bi, which were introduced when we removed left recursion from the production of variables ai, their productions should also be in GNF. To make their productions in GNF, we will use substitution rule. It would be more clear after this example. Suppose there is some grammar whose productions are these. These are the productions of some grammar. Now, what we have to do? We have to convert them into GNF without affecting the language of grammar G. First of all, what we have to do? We have to make the productions of grammar in Chomsky normal form. But these productions are already in Chomsky normal form. So first of all, what will we do? We will rename the variables of this grammar G as a1, a2, a3, a4 up to an if there are n variables, right? And a start symbol S will be renamed as a1. So here S is renamed as a1, variable a is renamed as a2, variable b is renamed as a3. Now these productions will become a1 derives a2, a3, a2 derives a3, a1, a2 derives a, a3 derives a1, a2, a3 derives b. After renaming the variables, what we have to do? We have to modify the grammar so that its productions are in the form ai derives aj gamma, where j is greater than I, or in form ai derives a gamma. Now see this production. A3 derives A1, A2. It is not satisfying the condition. So here we will use substitution rule. We will replace this production by the productions which is obtained by replacing this variable a1 by the string which appears right hand side of the production of the variable a1, right? So a1 will be replaced by a2, a3. So the productions which we get after replacing a1 by a2, a3 is this one. a3 derives a2, a3, a2. Now again, this production doesn't satisfy this condition, right? So again, this production will be replaced in grammar G by the productions which are obtained by replacing this variable a2 by the string which appears right hand side of the production of the variable a2. So by applying substitution rule, we will get these productions. a3 derives a, a3, a2. A3 derives A3, A1, A3, A2. Now we have replaced this production A3 derives A1, A2 by these productions in grammar G. It means this production A3 derives A1, A2 has been removed from grammar G. In place of that we have these two productions. A3 derives A3, A2. A3 derives A3, A1, A3, A2. Now this production A3 derives A3, A2 is in required form, but this production A3 derives A3, A1, A3, A2 is not in required form, right? It has left recursion, so it should be removed. Now we have these productions for variable A3. This production A3 derives A3, A1, A3, A2 has left recursion. Now we will introduce a new variable B3 in grammar G and eliminate left recursion. We will replace this production by these productions. A3 derives A3, A2, B3. A3 derives B3. A3 derives A3, A2. A3 derives B, and B3 derives A1, A3, A2, B3. B3 derives A1, A3, A2. Right. So this production is replaced by these productions in grammar G. Now in grammar G we have these productions. These productions of A3 are in GNF. A2 derives A, it is also in GNF, but this production A1 derives A2, A3, and this production A2 derives A3, A1. They are not in GNF. Now these productions B3 derives A1, A3, A2, B3, and B3 derives A1, A3, A2. They are also not in GNF. So what will we do? We will proceed from A2 to A1, right? And make their productions in GNF by substitution rule. Now see this production of A2. A2 derives A3, A1. It is not in GNF. So what will we do? We will apply substitution rule. So what will we do? We will replace A3 by the string which appears at the right hand side of the production of variable A3, right? Now A3 has these productions, right? So after replacing A3 by the right hand side strings of production of variable A3, we will get these productions for variable A2. So this production will be removed and these productions will be added to grammar G. That is, A2 derives A, A3, A2, B3, A1. A2 derives B, B3, A1. A2 derives A, A3, A2, A1. A2 derives B, A1. A2 derives A. Now see, these all productions are in GNF. Now see this production. A1 derives A2, A3. It is also not in GNF. So again we will apply substitution rule and we will replace this production by the productions which are obtained by replacing this variable A2. By the strings which appear at the right hand side of the productions of variable A2. So after applying substitution rule, we will get these productions for variable A1, which all are in GNF, right? Now see the productions of B3. They are not in GNF. First of all, see this production. B3 derives A1, A3, A2, B3. It is not in GNF. So again we will apply substitution rule. We will replace this production. B3 derives A1, A3, A2, B3. We will replace this production by the productions which are obtained by replacing the variable A1 by the string which appears at the right hand side of the productions of variable A1. So we will get these productions, right? So we will replace this production by these productions in grammar. It means this production will be removed and these productions will be added in grammar. Now see this production of P3. It is the last production which is not in GNF. So what will we do? We will replace this production in grammar G by the productions which are obtained by replacing the variable A1 in this production by the strings which appear at the right hand side of the production of variable A1. So we will get these productions. So from grammar we will remove this production and add these productions in place of this production. So see, now all productions of grammar are in GNF, right? Thank you very much.